Welcome. In this lesson, we'll learn about multiple cash flow and how to analyze its value in the present and future. So just a recap, in the previous lesson, we learned about single sum cash flow, and it's basically a single value and it's either in the present and I need to calculate the future, or it's a future and I want to calculate its present. And we've seen the use of factors or the use of formulas or the use also of Excel sheet functions. So, but the thing here is projects don't usually have just a single sum cash flow. Their cash flow will include multiple cash flows or multiple sums that happen or multiple flow of cash that happens through the life of the project. And these are just examples of these flow of cash. So in the beginning, you will have a capital improvement costs, and then over the life of the project, you will have revenue, maintenance, operation, and at some point during the project, you need to rehabilitate that asset or rehabilitate the road or rehabilitate the equipment or machine. And at the end of the project, there will be salvage, meaning that you will the project or the equipment reach the end of its economic life, and at that point you will have to either buy another equipment or rebuild the project. And in this case, you will demolish or sell this equipment as a salvage equipment, and that selling or kind of getting the value out of this asset at the end of its life is called salvage value. So you see here multiple cash flows in the life span of a project. So we need to make a kind of elevate our analysis from just a single sum to multiple sum. Over the next videos, we will, including this one, we will see how to analyze multiple cash flows, and we'll start with the generic one, that there is no pattern or like a pattern, meaning that it's not increasing in a specific rate, or it's not a fixed amount every year. So that's the case we'll see in this video. So a generic look of a multiple cash flow or a series of cash flow, that every year you will have a value, either positive or negative. And the idea here is we are trying to calculate the present worth or PW or P of these multiple cash flows that happen at different years. So the present worth will be the sum of the present values of all the cash flows that happen during the lifespan here. So this means that P is equal to A1 times 1 plus I to the power minus 1. So kind of I'm bringing its value to the present. A2 the same, but now you see it's to the power negative 2. So I'm discounting this value for 2 years, A3 for 3 years, and keep going like that. So I will end up with this generic formula here, that the present worth of a cash flow is the sum of the present worth values of the cash flows that happen over the years. Of course, that's the formula way. So I can use the formula 1 plus I to the power negative t or n, or I can use the factors. So I will add my summation here. Every term will have a factor that I can get the value of it from the tables, like we have seen in the previous lesson. So let's see this example here. We have this cash flow with different revenue amounts, so over 5 years, and this revenue is the result of a capital improvement cost or investment here. And what we are interested in is analyzing this cash flow to get the present worth. knowing that our interest rate or the time value of money is equal to 10%, and it's compounded annually. So if I show here the way we're going to solve that, so we have the cash flow and we're looking for the present worth. So kind of what we're doing is we're getting an equivalent cash flow, a single sum equivalent cash flow with one value at time 0. And this value can be positive or negative depending on the calculations and what's the outcome of it. So the present worth here is the unknown. And the present worth, I will start with the end of the cash flow, so the 50,000. I'll bring it to the present by a factor of P given F, 10% and 5 years, from year 5 to 0, so 5 years. I will do the same for 40,000. It's the same factor P given F, but a different year, number of years 4. And I will keep doing the same for all other cash flows until here 50k, P given F times 10% and 1. And the last one, don't forget it, which is the capital improvement or investment. And I have to pay attention here that it is negative 100k, P given F 10% and 0, because it is in the present and I want its value in the present. So this factor will be 1, because P given F is 1 plus I, so 1.1 in this case. So 1 plus 0.1 to the power negative n, and n in this case is equal to 0. So anything to the power 0 is equal to 1. So looking at the tables, this is kind of just zooming in into that page in the tables that represents 10%. And the P given F is the second column in this table. And just grabbing here and picking up the values of the different factors I'm dealing with. So 50k times P given F 10% and 5, this is the value. And if you keep going with the different values, and of course the 100k, like we've seen, has a factor of 1. And when you calculate that, you'll find that your present worth is equal to positive 59,418 and 20 cents. Now, so what? Like, what's this value representing? The present worth here, the value has no absolute meaning, meaning that it doesn't mean that the project worth is 59,000. It doesn't mean that you're achieving profit of this amount. But what's really matters to us here is that the sign here. So if the present worth is equal exactly to 0, this means that the investment return is exactly the equal to the considered value of the time value of money. So this means that the return of this investment is exactly 10%. If the present worth is 0, this more than 0, this means that I'm getting the return of this project here is more than the time value of money that's provided here, which is, if my time value of money is 10%, this project is actually providing more than 10%. How much? It's actually a different analysis we'll learn how to do, which is called the internal rate of return. So this is the case when present worth is more than 0. The next case is, the third case left is present worth is less than 0, which means that the return of this project is less than my time value of money. So this means that probably for me, if my value of money is 10%, this project is not for me. But maybe someone with a time value of money of 2%, this project might be attractive for that person. So at the end here, we calculated the present worth, and we are able now to kind of reflect on, is this a good investment, or is this a good project financially, from financial perspective, or not? So kind of this is the answer we got by paper calculations, or also I can use Excel. So I'm showing here the 3 ways, or the 2 ways of calculating the same thing we just calculated here. So P given F factors, I can get it from the tables, calculate the present worth like this, or use the Excel function PV, and it will give us pretty close answer to what we got before. And of course here, what does it mean to say that the net present worth or value is equal to this amount? Like we said, it doesn't have an absolute meaning, but the good thing here, it's positive. So it is, we are getting our 10% time value of money and even more than this. The other thing we can do with this type of series of cash flow is, instead of calculating its present worth, I can also calculate its future worth. And it's the idea here is that the future worth of the series is equal to the sum of the future worth of or the future values of all cash flows in that series of this project. So we'll end up with the future worth is the sum of every cash flow in every year times 1 plus I to the power n minus t. Just the formula here just says, if I'm calculating the future worth at the end of year 7, then if I'm dealing with the future worth of A3, I will bring it by 7 minus 3, so 4 years. It will gain value over 4 years. So that's the thing here. We are doing the n minus t, the meaning here. Always when we ask for to calculate the future worth of a cash flow, I'm calculating the value of all cash arrows here that I have at the end of the last year. So if this, let's say this investment is 20 years, I'll calculate everything, the value of everything at the end of 20th year. And of course, like we used before, the P given F for the present worth, now I can use F given P for the future worth. So let's revisit this example and calculate now, instead of the present worth, I will calculate the future worth. So if we do that, give me a minute just to open it. So now it's the same example, but we are looking to calculate the future worth. And what happens is we're just getting the equivalent cash flow that's just made of one single sum cash flow at year 5, and it's equal to and equivalent to that cash flow that we have originally given to us. So the future worth, I will deal with every arrow here, or every cash flow, and bring its value to the future of this cash flow series, which in our case here is the end of year 5. And for this 50K, I'm calculating the value exactly where it is currently. So I will end up here with this factor to be equal to 1. And you can see here it's 1 plus I to the power n, or the time difference. And my time difference here is 0, so the factor is equal to 1. For 50K, I'm dealing with F given P 10% and 1. And let's keep going here until we cover all cash flows in that series. And of course, don't forget the initial investment of 10 and 100K, and the difference in year 0 is 5. So this is the column now in the table that's representing the factors F given P. And 50K is just a factor of 1. And if I look at the other value, next value is 40K. F given P 10% and 1, and it's equal to 1.1. Makes sense, because if I'm just moving its value over 1 year in the future, I'm accumulating 10% interest, so it's 1.1 factor. And we'll keep going until I get all the factors, until I finish all my calculations for the cash flow, and I'll end up here with a future worth of 95,694. Again, the question there is, so what? What's this value representing? Similar to what we discussed in the present worth, this has no absolute meaning, but future worth here, when it's equal to 0, this means exactly the return of this investment is exactly the same time value of money that I used, or I that I use in this example. If it's more than 0, the good, actually better news, the return is more than the time value of money that I'm asking for. If it's less, it's bad news for me, but maybe other people with less time value of money will accept this investment. So that's the That's the same cash flow we analyzed but calculated the future value. Now this is kind of expanding that table in Excel that we showed before to show the future worth calculations. So f given p, these are the factors we figured out from the tables. We've multiplied the future every one of these factors times the cash flow, and you will end up with the values here. Add them up, you will have the future worth of the whole thing. Or you can use the FV function in Excel. Now, question here, is there any relationship between these two values that I calculated, the present worth and the future worth? I will give you a moment, just think about it. They come from the same cash flow. So they kind of equivalent, different equivalent formats or different equivalencies of the same thing. So is there a relationship? Because they are kind of indirectly related to each other because they come originally from the same cash flow. So we will illustrate that by going through here the steps. So the first thing here, when I analyze the first example, I transform this original cash flow into this single sum cash flow or the present worth by P given F. So I did many P given F's, P given F factors. And then the second example, I transform the cash flow into a single sum, but this sum is in the future of the cash flow using multiple F given P's. Now, if I'm thinking about it, if I have the present worth, I actually can calculate right away the future worth by multiplying this value F given P. So they are related because that value present worth is just squeezing the value of the whole cash flow into a value in the present. The future worth is squeezing all the value of the cash flow in the future in the value in the future. These two values are equivalent, and the relation between them is just if I move the present to the future, it's multiplying it by F given P, or I can bring the future to the present by multiplying it by P given F. I'm given the F and I need P. How to prove that? Just let's play dumb and just say, if I have the present worth, let's calculate the future worth. So the present worth I did the long way, like we've seen before. Now I'm using F given P factor, and the difference between the present and the future is the lifespan of this cash flow, which is 5. So from the tables, it's 1.61051. And if you do the calculations here, it is bringing us the value pretty close to the future value that I calculated the long way. If I do it the other way, so if I want to calculate the present worth, knowing the future worth that I have, I'm using now the P given F factor. So getting the factor for P given F, which is 0.62092, and that will bring me the present worth the same value that I got from the previous example. So just remember that when you calculate a worth of a cash flow at any point, it is a representation of that cash flow, and you can move that worth anywhere in the timeline. So move it to the future or move it to the present. It is just squeezing that as a worth of the cash flow. That worth can be present or can be future or even can be in the middle. I can calculate the worth of this cash flow at the end of year 2 if I want. So this is the third example, just to make sure we all understand now the process, and we are only focusing here on the present worth. So for this one, it's given to us as a table, and we would like to calculate the present worth. And we're given I, or the time value of money, is 10%. So if I draw the cash flow for this, I have here 8 years, and these are the different cashes or cash flows that happen at different times. And if I want to calculate the present worth, I have to deal with each one of these cash flows separately times its factors. So if I'm bringing everything to the present, then this 300 at year one, I discount 1 year of it, of its value, by multiplying P given F 10% on 1. And then the second 300, I'm dealing with 3 years difference. This 204-year difference. And you keep going along until the end, until you cover every piece of this cash flow. And bringing the tables again, P given F is the second column, and just keep getting the values of the factors you have. And you have all the factors, multiply them by the cash flow values, and you will end up with present worth to be 503.03. So a simple example will just show you another case of calculating present worth. Now I will leave you with this task. Calculate the future worth in this detailed way. So every cash flow, bring it to the future by its own F given P factor. And then do the same thing we did with example 1 and 2. Compare the future worth that you will calculate in a detailed way. Compare it to the present worth that we just calculated now. And you will find that same P given F, F given P relationship that we explained before. So that's it for this video. How to deal with multiple cash flow analysis, a series of cash flows that doesn't have any patterns. So we have to deal with every cash flow individually. We learn how to summarize or kind of squeeze the cash flow into worth or its worth or value at either the present or the future. All right. Thanks for watching and take care.